Hello students, now let us start today's session. In today's session we are going to start a new study note, that is study note number 2. Now study note number 2 is a very easy study note. It's a scoring study note. Now in this study note, basically what we are going to do, we are going to evaluate risky proposals. We are going to evaluate risky proposals for investment purpose. Now, before starting this chapter, we need to understand the meaning of risky and non-risky. So, first of all, first target will be to make you understand the difference between proposals which are risky and which are non-risky proposals. Then how are we going to evaluate risky proposals? So there are going to be various methods of evaluation, or we can say decision making. Regarding what? Decision making regarding that whether we should go ahead with the risky proposal or not. So for that we are going to learn various methods how we evaluate the risky proposals. There are going to be 8 to 9 ways how we can evaluate or take a decision whether we should go ahead with the risky proposal for our investment or not. Now what are the 8 to 9 methods or ways that we have to learn in this chapter? The first important method is certainty, equivalent, factor. In short form it is called CEF. We are going to start this chapter with this concept, certainty, equivalent, factor. Then we are going to study your probabilities, which is very important, because probability because of the probability there is origination of risk. So to understand the meaning of risk, we need to know the probability, that is certainty and uncertainty. That is your joint probability we have to learn. Then we have to learn how to measure risk, measurement of risk. That we have also done in portfolio chapter. We have studied standard deviation, we have to do it again. So standard deviation we have to do, measurement of risk, probability, joint probability concept. Then we have to do while studying joint probability, we are going to do decision tree analysis. Now decision tree analysis is one of the way to evaluate risky proposals, and through using the concept of joint probability. So this is an important concept, that is decision tree analysis. Then we are going to do sensitivity analysis. This is again very important. We all know that in capital budgeting also we decide whether we should invest in a proposal or not, and the most important tool which is used in capital budgeting is NPV. So we are still going to calculate NPV, net present value, future value, everything we are going to do, but now we are going to compute NPV using these methods. So we are going to amalgamate the NPV concept and these new concepts also. Okay, sensitivity analysis also will amalgamate NPV concept. Okay, this is then the next concept that we are going to do is, after sensitivity analysis, we are going to do simulation. Then we are going to do the simulation concept you must have done at inter level also, but we are going to do it again. Then we are going to do concept Z value concept. Then we are going to do Hiller's model. So all these concepts we are going to do hopefully, and yes, RADR concept, that is risk adjusted discount rate. These all concepts we are going to do. Certainty, equivalent, factor, one of the very important concept through which we are going to start our chapter. Now before starting this chapter, we need to understand one very important concept, that is time value of money. Now this concept needs to be learned properly before starting this chapter, because every logic starts from this concept. Okay, so time value of money concept can be understood in two parts. One is its practical aspect. Practical aspect means that how to compute present value, how to compute future value, which we have learned in the basics of leasing chapter, right? Basics of leasing chapter, you can watch that video, basics of leasing chapter. You know how to compute present value, you know how to compute the future value of cash flows. How do we compute? If you want to compute present value, you will be given future value of cash flows, you have to multiply with present value factor. If you want to compute future value, present value will be given, you have to multiply with future value factor. With all explanation, we have made you understood this. Now we have to understand this time value of concept conceptually. Now conceptually also I have explained it in the chapter of Forex, but maybe some students might not have studied Forex. So I am going to take 10 to 15 minutes again to explain this time value of concept again in this chapter conceptually. Okay, and then we are going to start this chapter with this concept certainty equivalent factor and then proceed over. Okay, so once again I must tell you this study note is very easy. There are around 14 questions in your study module, 14 questions in your study module, CMA module, and around 20 to 25 questions are there in our conceptual part. So what we are going to do this time, we are going to understand the concept and also simultaneously do the CMA module question along with the concept. So if I'll finish certainty equivalent factor, I'll finish the conceptual question, and as well as I will do the study module question also, because these are very easy questions. And one more concept is there which I have not mentioned, that is value of perfect information. This is also covered in your CMA module book. Okay, so let us start this chapter. First we'll understand the time value of money concept conceptually. Concept, time value of money. Time value of money. Now we all know with passage of time the value of money increases. Now there are two questions. Why time value of money, that is why value of money increases, why value of money increases with time? And the second question that we should answer is how much value increases, how much value is increased with time, how is it decided? So basically we should understand with passage of time value of money increases, why it increases and how much it increases. So in the Forex chapter also I gave the same example that I am going to repeat again. For example, I have 100 rupees with me. This is my capital. Now I can keep this capital with me, or I can invest this capital in any proposal, in any project also. So there is Mr. A. Mr. A is asking a loan of rupees 100 from me. So Mr. A is asking a loan of rupees 100 from me for 1 year. Now I'm thinking whether I should give this 100 rupees to Mr. A or not for 1 year. Now if I give 100 rupees to Mr. A for 1 year, then I will not be able to use this money for myself, because now this money belongs to Mr. A for 1 year. So if I give Mr. A rupees 100 for 1 year, then after 1 year, how much Mr. A will return me? How much Mr. A will return back? Mr. A is saying that ma'am, you gave me 100 rupees, so I will return you 100 rupees. Simple. Answer is not that simple. I gave Mr. A 100 rupees, so should I get back only 100 rupees or should I get back something extra over and above 100 rupees? Should I get only 100 rupees or should I get something extra over and above 100 rupees? So over and above 100 rupees. I asked Mr. A that I should get more than 100 rupees. So Mr. A is asking me, why ma'am you should get more than 100 rupees? You gave me 100 rupees. Now you should get back 100 rupees from me only. Why should I give you something extra? So the answer to his question is that since I am giving him money, please listen to this carefully. since I am giving him this money, I will not be able to use this money to buy anything. Since I have given him the money, if I would not have given him money, I would have purchased either 1 kg of apple or something. I would have used this money. After giving him money, after giving loan, I have postponed the usage of money. Since I have postponed the usage of money, now I am not able to use my money for 1 year, I need compensation for the same. Compensation for the same. So I am telling Mr. A, I need 100 rupees as well as some compensation. So now Mr. A have understood that why I should get something extra. Because I have postponed the usage of money, the consumption of money for my use. So therefore I need some compensation. Otherwise I could have purchased 100 rupees of apple. So 1 kg of apple, but I am unable to now purchase this. So hence I need some compensation. So first question is answered. That is why value of money is increasing. After 1 year, 100 rupees does not remain 100 rupees. 100 rupees increases because the consumption has been postponed. Okay. Now the second question is how much extra Mr. A should give to me. So the answer to this is yes. So answer to this is if I would not have given money to Mr. A, I would have purchased, suppose let us say from 100 rupees, I could have purchased 1 kg of apple. But if I give him money, after 1 year, at least I should be able to purchase the same apples which I could not purchase because I have given money to Mr. A. So at least after 1 year, I should be able to purchase the same apples. Now during 1 year, there is an inflation of, let us say, 10%. So the same apples now would not cost 100 rupees, it would cost 110 rupees. 1 kg of apples. So basically, I should get rupees 100 from Mr. A plus I should get 10 rupees extra, that is 10% due to the inflation. Inflation is the reason behind it. Hence, after 1 year, Mr. A should give me extra how much? At least minimum inflation, so that I am able to purchase the same commodity which I was able to purchase 1 year back. So basically, the first reason of time value of money, that is why value of money increases, is because of the inflation. If inflation was 8%, then Mr. A has to give me 108 rupees. If inflation is 12%, then Mr. A has to give me 112 rupees. So the first reason why value of money increases is inflation. Now Mr. A is asking me, should I give you only 110 rupees or something extra I should give him? So I am giving him the second reason. I need more. So he's asking me, why you need more? Why not only 10 rupees and be happy with it? So the second reason is, if instead of giving Mr. A money, if I would have invested 100 rupees in a risk-free investment, let us say if I would have done a fixed deposit with the bank or something like that, fixed bank, then the risk-free rate of return, let us say, is, let's say 16%. So if instead of giving the money to Mr. A, I would have invested my money in a risk-free investment, I would have got 16% return. Suppose bank is offering me 16% return. So bank will be giving me rupees 116 after 1 year. Now after 1 year, if I will receive 116, then from 110 rupees, I will purchase 1 kg of apple. And I'll be left with rupees 6. That is my real rate of earning or return, we can say. So 6 rupees on 100 rupees is how much? 6%. So basically, can I say 6% is my real rate of earning? So can I conclude like this, that if I would have invested my money in a risk-free investment, I would have got Yes. If I would have invested my money in risk-free investment, now the return which we get from risk-free investment is called nominal rate of return. Now nominal rate of return is 16%. Now this 16% can be bifurcated in two parts. One is your inflation rate. That is, even though you are getting 16% from bank as a risk-free rate of return, but your rate of return you're earning is not 16%, only 6%, because 10% is eaten up by inflation. So inflation takes your 10%. Only your real rate of return is 6%, right? So basically now I'm going to tell Mr. A that if I would have invested in risk-free rate of return, I am getting 16% return. So at least you should give me this much. So the second reason is that is the inflation. So now I can conclude that the time value of money, that is the value of money increases, value of money increases because of two reasons primarily. One is your inflation. Whatever the inflation rate is in the country, accordingly money value will increase, as well as the real rate of return. Now this is a very good reason if the value of money increases, because this depicts your GDP growth rate. This rate is basically depicting that how your country is growing, how your technologies are growing, how that because of this reason if your money is increasing, value of your money is increasing, then it's a good reason. So GDP growth rate, the rate at which your country is growing, your technologies are growing, your infrastructure is growing, that is the rate. This is the rate. So this is your real rate of earning, because remaining 10% is eaten up by inflation. So real rate of return, and both together is called nominal rate of return. Okay. So now Mr. A is asking me, okay, finally now I have to pay you 16%. So answer is no. I need more. Now he's saying you need more. I said yes, I need more. I need more than 16%. Then now he's asking me, why do you need more than 16%? So the answer is reason number 3. Am I investing in a risk-free investment, or am I giving my money to Mr. A? I am giving my money to Mr. A, and Mr. A is not a risk-free investment, is not a risk-free investment. Mr. A is not a risk-free investment. Mr. A can make a default. Mr. A has got uncertainties attached to him. He might not return back my money. He might not return me the rate of return which I am asking from him. There is a chances of default. So since I am investing my money in a risky investment, if I am investing my money in a risky investment, why would I invest my money in a risky investment when I can earn 16% from a risk-free investment? Why would somebody choose to invest his money in a risky proposal instead of risk-free proposal? Obviously, he want more return, then only you will choose a risky proposal. Therefore, I am telling Mr. A, since you are a risky proposal, risky investment proposal, therefore, I need more extra, or should say return. Now this return is called risk premium. If I would have invested in risk-free investment, I should have got 16%. But since I am going to give my money to you and you are not a risk-free investment, you are a risky investment, I need risk premium. I need something more. Why? Otherwise, why would I choose to give my money to you? So first of all, now I need time value of money. That is, money value is increasing because of 3 reasons. One is inflation rate. Whatever the country's inflation rate, that you have to give me, because then only I can purchase the same thing which I could have purchased the last year. Plus the real rate of return, that is the rate at which the country is growing. This together comprises risk-free rate of return or nominal rate of return, whatever you like it to be called nominal rate of return. Now, since I am not investing my money in a risk-free investment, I am investing in my money in a risky investment, I need some extra return which is called risk premium. Now, this extra return can be 2%, 3%, 4% or any percentage depending upon the risk involved. Depending upon the risk involved. If more risk involved, more return I want. Now, how much return I should get? Additional return. Now, you know very well, you have learned CAPM model. First of all, you need to compute the standard deviation. Now, this is, we are going to learn in this chapter also. Standard deviation is a measurement of risk. Now, first of all, we will measure how much it is risky to give money to Mr. A. Now, once we are able to measure the risk, then we will compute how much compensation should we get for risk. Compensation for risk. That is how much extra return we should get. That is how much risk premium we should get. How much extra return we should get. That we are going to compute. So, this we are going to learn. So, this portion varies depending upon the risk involved in your proposal. So, basically, time value of money differs with every proposal. This is one of the very important thing, that these two portions remain constant. Whether you invest in your money in project A, project B, project C with Mr. B, C, D, E, F, anywhere, inflation and real rate of return, that is the risk-free rate of return, so you should get plus whatever the risk is involved in the proposal or with the person concerned. Accordingly, compensation should be given. Otherwise, why would I invest my money in a risky proposal? So, I should be getting risk premium. So, these three factors, this keeps on varying. So, total, suppose Mr. A, I am asking from Mr. A 2% return. So, 10 plus 6 plus 2. So, total 18% I should get from Mr. A. So, hence, with the deviation in the risk, with the variation in the risk, if risk is more, I need more risk premium. If risk is less, I need less risk premium. So, now I know with passage of time, the value of money increases. And why value of money is increasing? It is attributable to three factors: inflation, real rate of return, and the risk premium. Okay. So, now let us start the concept of certainty equivalent factor. And this concept is very important. Why we have studied this? Because we need to understand why value of money increases, because when there is a risky proposal, we need something extra. So, if you see this last concept, risk adjusted discount rate, here also time value of money concept will also come into play, as well as in certainty equivalent factor also TVM concept will come into play. So, let us start this concept with the base ready for us. Okay. And if any student wants to write, they can pause the screen and write it down. I was explaining time value of money concept. This I have already explained in the Forex chapter also. You can pause the screen and write it down. I am changing the sheet. Yes, now let us start the concept. Concept number 1, that is certainty equivalent factor. Now, this in short it is called CEF. Now, there is a formula of CEF which we are going to understand and create also, but the formula is your certain cash flows upon uncertain cash flows. Certain cash flows upon uncertain cash flows. Now, please observe an example. Through that example, I am going to explain the uncertain cash flows, certain cash flows and the CEF concept. Okay. Then we are going to do a question. So, example is like this. Suppose I am constructing a house. I am constructing a house as on today. So, this is a project. in which I am putting my capital, my investment. Now in this project of construction of house, I am putting capital, construction of house, and I plan to sell this house after 1 year. I plan to sell this house after 1 year. Because during 1 year I am going to do the construction part. So after completing my construction, I am going to sell this house after 1 year. So now during after 1 year, I have done a research and I am expecting that this house would be sold for 6,20,000 rupees. Now I am not certain, because today I do not know how much money I will get after 1 year, but I have done my research and I am getting an estimation. Now this is an estimation that I will be getting 6,20,000 rupees after the sale. So now this amount 6,20,000 is not certain. I can get 6,20,000 rupees. I might not get also after selling this house this much amount. So this amount has uncertainties, because future is not certain. So this is uncertainty. It involves uncertainty whether there is a possibility that we might get 6,20,000 rupees, or we might get more also, we might get less also. Okay, so this 6,20,000 rupees is called uncertain cash flows. It is called uncertain cash flows, because uncertain cash flows. Okay, now I have talked to one of my friend and I am asking him that I have done my research and I might get 6,20,000 rupees. Can you buy my house? So with certainty, can you buy my house after 1 year with certainty? Now since I am asking him to purchase my house with certainty, that is, he's for sure going to buy my house. Now since you are going to remove the element of risk from this story, you want to become certain. So definitely you will not get 6,20,000 rupees, because 6,20,000 rupees amount involves risk. If you want to be sure that, okay, I'm asking my friend that will you purchase my house with certainty? So he's telling me, okay, I will purchase your house with certainty. Now the question is, will I be getting 6,20,000 rupees? No, because once you remove the element of risk, your value of money will decline. Okay, that we know. Now suppose if I say this project was for, this amount is still pending. We do not know with certainty how much amount we will get after sale of the house with certainty. Now we understand this concept from here. Suppose this construction of project and selling it after 1 year, that is the risk, let me say, the discount rate, let us say 14%, which involves the risk. Now this discount rate is a time value of money, that is, it includes the inflation also, it includes the real rate of return also, as well as it includes the risk involved in this project. So totally I should be getting 14% return. Now this is the future value. Now if I do a calculation, simple calculation, if I want to find out the present value of 6,20,000, that is the present value of this house, how should I find present value of this house? If I have been given the future value, I should multiply with present value factor. So 6,20,000 into PVF at the rate of 14% for 1 year. So basically 6,20,000 into 1 upon 1 plus 0.14. So that is 1 upon 1 divided by 1.14 into 6,20,000. So we are getting 5,04,3860. So basically, if I sell this house today, I should be getting 5,48,860. This is the present value of cash inflow. So can I conclude? Please understand this. What I'm trying to say is, if I sell this house today, I should be getting 5,43,860 rupees. And if I sell this house after 1 year, if I assume my time value of money to be 14%, then this house should sell for 6,20,000. Now this time value of money includes inflation, real rate of return, as well as the risk involved in this proposal, risk premium. Now if I say that the risk-free rate of return, please understand, if instead of constructing this house, if I would have invested this money in a risk-free investment, if I would have invested my money in risk-free investment, and let us say risk-free investment rate of return is 6%, then how much money should I get after 1 year? Can any student tell? Can compute after 1 year how much should I get if I invest this money for 1 year? 5 lakh for 3860 into 1 plus 0.06. Let me write it again. After 1 year, how much should I get? I should get 5,43,860 into 1 plus 0.06. How much should I get? I should get 5,76492. Now, what is this 5,76492? And what is this 6,20,000? Now, if we include the risk portion, uncertainties, then this house can be sold for 6,20,000. But if this amount is invested in risk-free investment, then with certainty, can I say with certainty, I will be getting a cash inflow of 5,76,492. This is certain cash flows. So when I was asking my friend that can you purchase my house with certainty, then with certainty, how much money should I get from my friend? Because with certainty, I can get the same amount from the bank also. So can I say, if we compare these two figures, please understand, with uncertainty we can say the house can be sold for 6,20,000 after 1 year. With certainty, it should be sold for 5,76,490, because from risk-free investment also you can get this much amount. So after construction of a house, you should at least get bare minimum 5,76,492 with surety. Now, if you see the present value of 6,20,000 is how much? 5,48,860, and the present value of 5,76,492 is also 5,43,860. Both these uncertain cash flows and certain cash flows have the same present value, because this uncertain cash flow is discounted at the rate of 14% and this certain cash flow is discounted at the rate of risk-free rate of return 6%. Now, what is the conclusion? The conclusion is that the same value as on today is 5,04,3,860. If we compound with 14%, it becomes 6,20,000. If we compound with 6%, it becomes 5,76,492. This is termed as certain cash flows, and this is termed as uncertain cash flows. Now, if you want to know how much is the proportion of certain cash flows to comparison with uncertain cash flows, that is, out of 6,20,000 rupees, how much is the amount of money which is certain that you will definitely get after 1 year if you sell the house? 5,76,492. So if you take a proportion of certain cash flows with uncertain cash flows, now this is coming out to be 0.93. Now this is termed as certainty equivalent factor. That is, out of 1 rupees, 0.93 paisa is certain that you will get after 1 year. If you divide 5,76,492 with 6,20,000, you get 0.929, that is 0.93 approximately. That is, from out of every uncertain cash flows, 93% is certain that you will get. Okay. Now, we have understood what is certainty equivalent factor. Factor always means 1 rupee. So, on 1 rupee, you are certain you were going to get 0.93 paisa. So on 6,20,000, you are certain you are going to get 5,76,490. And for both uncertain cash flows and certain cash flows, the present value is the same. This 14% is your discounting factor, and this is also discounting factor, but this includes the risk proportion, and this is the risk-free rate of return. Okay, now you have understood CEF is basically the proportion of certain cash flow to uncertain cash flow. Okay, now how does this helps, this whole example, how does this concept helps in taking the decision? So we are going to take a practical question from our conceptual book, and I'm going to explain you how we can decide whether we should go ahead with the risky proposal or not. Now this certainty equivalent factor says stop evaluating the uncertain cash flows. Simple question I'm asking you. Simple question. Okay, listen to this very carefully. Now, if you are thinking to invest your money in the construction of a house, and after 1 year, you know the risk-free rate of return is 6%, that is, you should at least get 5,76,492 from selling this house. At least certain cash flow, this must be this much. Now, if I tell you that you are not even getting 5,76,490, you are only getting, let us say, 5,60,000 rupees. Will you invest in this house? You will say, ma'am, no ma'am, we will not invest because we are not even getting 6% rate of return. So how did you decide whether you should go ahead with this construction project or not? Did you evaluate 6,20,000 amount? No, you did not consider the uncertain amounts. No, you first computed the certain cash flows. Then you checked whether the certain cash flows what you are going to get and what you should get. Now 5,76,492 is the amount that you should get with certainty. And if you are not even getting 5,76,000, you are just getting 60,000 rupees. You will say, ma'am, why should I construct the house? It's better to invest this money in the risk-free rate of return. At least I would be getting 5,76,492. With the same thought process, we are going to solve the question. We are not going to evaluate the uncertain cash flows. We are going to evaluate the certain cash flows. How we are going to compute the certain cash flows? In the question, it will be given certainty equivalent factor is 90.93. So what we are going to do? From this formula, if you see, CEF is, now if CEF is multiplied with UCF, you get CCF. Now what does this mean? Certainty equivalent factor, if multiplied with uncertain cash flows, you get the certain cash flows. So if you multiply the uncertain cash flows, in the question they will be giving you uncertain cash flows and CEF. So 6,20,000 if multiplied with 0.93, you will get certain cash flows. Now if the certain cash flows are not even equivalent to the risk-free rate of return, then you should not invest in this project. Now if after 1 year you are getting 5,76,492, then it is good, you should invest. If you are not getting 5,76,492 after 1 year, you should not invest. Now let us solve a question and understand this concept better. Now observe question number 8. This is the conceptual question. Okay. After this, we are going to do the CMA module question. Now the question says blueprint. You will understand CEF concept much better after solving this conceptual question. Question number 8. Blueprints Limited, whose cost of capital is 10%. Now this company's cost of capital, that is, it needs bare minimum rate of return. How much? 10% is considering a project. Cost of capital 10% means the people who are providing you capital, you have to give them a return of 10%. So wherever you're going to invest this capital, you need to earn 10%. So cost of capital is 10% is considering a project with the following expected cash flows. Okay. So this company is thinking to invest in a project which has the expected cash flows. The risk-free rate of return is 8%. NPV at 10%, if you compute NPV at 10% is found to be positive. Okay, we have learned at inter level that if NPV comes positive, that means we should undertake the project, we should accept the project. If NPV is negative, we should reject the project. We have also given you the logic in the conceptual lecture. Now see how we have to solve this question. Year 0, cash flows are 22,500. Year 0 means if currently you undertake this project, your outflow, your investment will be 22,500. First year, second year, third year, these are your inflows. Due to uncertainties about future cash receipts, the management decides to adjust these cash flows to certain equivalent by taking 60%, 55%, 50% of cash flows of year 1 to 3 respectively. See, they are saying due to uncertainties of future cash flows. Future is totally uncertain. You are saying that every year you're going to get this cash flow, 17,500, 12,500, 12,500, but this includes uncertainty. Now, if you management decides to adjust these cash flows with certainty equivalent factor, that is 60%, 55%, 50% of cash flows of year 1 to 3 respectively, implying that 60% of 17,500 is certain, 55% of 12,500 is certain, 50% of 12,500 is certain. Okay, assess the viability of the project. Now, how we are going to assess the viability of the project even though knowing that NPV is positive at 10%? See how we are going to solve this question. Now, in this question, answer number 8. You have to first understand this question. The company's cost of capital is 10%. Now, if you take this as a discounting rate, your NPV is coming positive. At this, NPV is coming positive. So, this implies the project is good. That is, project is giving you more than 10% return. NPV positive means that project is giving you return which is more than 10%. You should be happy because your capital providers, your people who are giving you capital are asking 10% return, and if you invest this money in a project, it is giving you more than 10%, so you should be happy. But see how we are going to evaluate with certain cash flows. Now, in the year 0 means as on today. If as on today your cash investment or outflow is 22,500, right? Okay, and years, if you consider inflows, every year cash inflow is how much? These cash inflows are uncertain cash flows. They are not certain. They can occur, they cannot occur. These are 17,500 and this is 12,500 and this is 12,500. Now let us first step number 1. What are you going to do? You're going to compute certain cash flows. Now, first of all, let us write certainty equivalent factor. In the question, it is given that 60%, 55% or 50%. Either they will write percentage or they will write 0.60, 0.55, 0.50. Now, we are going to compute certain cash flows. If you include the uncertainties, this is the cash flow you might get. But with certainty, you will definitely get 60% what may happen. So let us find out. 17,500 into 60% is 10,500. Now this is certain cash flows, CCF. Okay. Then 12,500 into 55% is 6,875 is the certain cash flows. And then 12,500 into 50% is 6,250. These are certain cash flows. Now, this is the certain cash flows. Forget uncertain cash flows. Now, we know very well that the risk-free rate of return is how much? 8%. Now, wherever you invest your money, at least you should get a return of 8%. So, let us verify This is, I'm writing for you, tutorial note, don't write in paper. Wherever you invest, wherever money is invested, with certainty, at least 8% return should come. Now let us verify whether 8% return is coming or not, 8% return is achieved or not. So we are not going to talk about uncertain cash flow. Let us see whether certain cash flows, if we invest as on today 22,500, what we are getting this certain cash flows. Let us see whether these certain cash flows are growing or increasing at the rate of 8% or not. How we are going to check? On the next page we are going to solve this question. Now what we are going to do, year 0 cash outflow is how much? 22,500, right? This is cash outflow. Year, now 1, 2, 3. Now what is your certain cash flows that we have just computed? We are going to write that. Certain cash flows are these: 10,500, 6875, and the last one was your 6250, right? Now these cash flows you are going to get after 1 year, 2 year, 3rd year. These cash flows are compounding. Now let us check whether they are compounding at the rate of 8% or not. If they are compounding at the rate of 8%, and if we discount these cash flows, because these cash flows you are getting in future cash flows, so if we discount at the rate of 8%, it should come equal to 22,500. Let me repeat it once again. Let us verify at what rate these let us verify whether these cash flows are compounding at the rate of 8% or not. If these cash flows are compounding at the rate of 8%, if we discount these cash flows at the rate of 8%, it should come equal to 22,500. Why, ma'am? Very simple. If rupees 100 is compounding at the rate of 8%, it becomes 108 after 1 year. So if I discount 108 rupees at the rate of 8%, it should be equal to 100 rupees, right? So let me check. Let me find out the present value of these figures. How do we find present value of certain cash flows? How do we do that? We multiply, these are future value, we multiply with present value factor at the rate of 8%. Now we know how do we compute? 1 upon 1 plus 0.08, right? So how much it is coming? 1 upon 1 plus 0.08. This is for your explanation, dear students. 1 plus 0.08 square into 1 plus. So on calculator, what we are going to do? We are going to 1 divided by 1.08 equal to, this is coming out to be 0.926. Okay, then equal to, again this is coming out to be 0.857. Then again equal to, we are going to press 0.794. So if we multiply the future values with the present value factor, we get the present value of these figures. So if 10,500 multiplied with 0.926, we get 9723. What does this mean? That if you invest 9723 today, after 1 year at the rate of 8%, it will become 10,500. Now if we multiply 6875 with this figure, we are getting 5892. What does this mean? That if you invest today 5892, after 2 years, if the rate of money, increasing money is 8%, it will become 6875. Now 6250 into 0.794, it is coming out to be 4963. So 4963 implies what? That if you invest 4963 today, after 3 years at the rate of 8%, it will compound to 6250. So if you want these 3 certain cash flows today at the rate of 8%, you should invest present value of certain cash flows. Cash inflows is how much? This is coming out to be 9723 plus 5892 plus 4963. So 20,578. This much you should invest today if you want to earn at the rate of 8%. Now, are you investing 20,578 rupees? No, ma'am. Ma'am, we are investing 22,500 and still we are getting only this much certain cash flows. Present value of cash outflow. So, minus 22,500. So, 1922 negative. Negative NPV is coming at the rate of 8%. Your NPV is negative. What does this mean? That with certainty you are not even getting 8% return. See, with uncertainty you might be getting 10% return. But before going to the uncertainty aspect, at least on your money you should with certainty get risk-free rate of return. This is what is all about certainty equivalent factor concept says, that while evaluating a risky proposal, forget the risky uncertain cash flows. First, think whether you are getting the return with certainty, how much. Now, in this project, you are not even getting 8% return with certainty. So, even though you get 10% return with certainty, that doesn't matter if you are not getting bare minimum rate of return with certainty. So hence we can conclude that in the given project NPV is negative with discounting factor 8%, which is risk-free rate of return. Hence, project should be rejected. Now, I hope you have understood. Now, what are the steps involved in certainty equivalent factor concept? First of all, in the question, they will be giving you uncertain cash flows. Now, we are not going to, we are going to evaluate uncertain cash flows, but we should at least see whether this project is giving you with certainty 8% return or not. Then on the second level, we are going to check. So we are trying to teach you here that with certainty 8% return should come. Risk-free rate of return the project should achieve at least. So step number 1, uncertain cash flows are multiplied with CEF to derive the certain cash flows. Then you compute the NPV of the certain cash flows. NPV is what? Present value of cash inflow minus present value of cash outflow is NPV. Now, what does this NPV denotes? That in order to get this much of return at the rate of 8%, this much should have been your investment. But you are investing 22,500 in actual. So basically you are investing more and still you are getting this much of return only. So that means you are getting less than 8% return. NPV negative denotes this. Now, let us write some steps of the certainty equivalent factor. Steps. Method of computation under CE approach, that is certainty equivalent approach. Step 1, convert uncertain cash flows to certain cash flows by multiplying it with certainty equivalent factor. So basically certain cash flow is equal to uncertain cash flows into certainty equivalent factor. Now step number 2, after computing the certain cash flows, Then you have to discount, that is you have to find out the present value, discount the certain cash flows at the risk free rate to arrive NPV. Step number 3, if the resultant NPV is positive, the project can be accepted. Now let us go on to question of CMA module. Let us do the question of CMA module. Yes, question number 6. Now the globe manufacture, simple question it is. I told you this study note is very simple. You will find almost all concepts very easy. Okay. The Globe Manufacturing Company Limited is considering an investment in one of the two mutually exclusive proposals, Project X and Y. So, two mutually exclusive projects are Project X and Y, which requires a cash outlay of 3,40,000 and 3,30,000 respectively. So there are two projects X and Y. We have to evaluate them separately. In Project X, 3,40,000 is the investment. In Project Y, there is 3,30,000 rupees of investment. Now, what is mutually exclusive proposals? Mutually exclusive proposal means that if you accept proposal X, Y will be automatically rejected, and if you accept Y, X will be automatically rejected. Basically, both cannot coexist together. You have to either make an investment in X or in Y. You cannot make an investment in both the projects. So they are not independent projects. If it is written independent projects, it implies that both can be accepted. But if it is written mutually exclusive project, that means only one project will be accepted, other will automatically be rejected. Both cannot be together accepted. Okay, so both cannot be together coexist. Fine. Anyways, we have to evaluate separately and then see in which project we can invest. In Project X, this is the investment amount, 3,40,000, and in Project Y, 3,30,000 is an outflow. The certainty equivalent approach is used. That is, we just have to check whether these projects are earning with certainty the risk-free rate of return or not. In incorporating risk in the capital budgeting decision, the current yield on government bond is 10%, and this can be used as riskless rate. So 10% is your risk-free rate of return. Okay, so basically we have to check whether these two projects are giving us risk-free rate of return of 10% or not. The expected net cash flows and their certainty equivalents are given to you. So expected from Project X, you can expect a cash inflow of this cash inflow, this cash inflow, and this cash inflow. And with certainty, if you want to know, then you have to multiply with certainty equivalent factor. Okay, so certainty equivalent factor is given to you 0.8, 0.7. Yes, again, cash inflows are given to you, but these are uncertain cash inflows. You have to multiply with certainty equivalent factor to get the certain cash inflows. So basically, 1,80,000 is an uncertain cash flows. It can come, it cannot come, but 80% of this is certain. Okay. Similarly, for Project Y is also given, certainty equivalent factors are also given. Present value factor of 1 rupee discounted at 10% at the end of year 1, 2, 3. So PVF is also given. We could have is also computed by ourselves. Which project should be accepted? First part. And second part, I will try to explain, but we have not yet studied the risk adjusted discount rate. If risk adjusted discount rate method is used, which project should be analyzed with higher rate? That I'll make you understand. But first, which project should be accepted? Project that will be accepted which has positive NPV, which is giving you with certainty at least 10% rate of return, which is risk-free rate of return. So using all these figures, let us solve the question. Yes. So let us evaluate step number 1. CMA module question number 6. Now evaluation of, let us do evaluation of project X. So evaluation of proposal या project X. Now how we are going to do? First of all, we are going to write years, that is years 1, 2, 3. Now let us write uncertain cash flows. Uncertain cash flows are given to us 1,80,000 is given in the question. Then 2 lakh and 2 lakh. Then we are going to multiply it with certainty equivalent factor. How much is a certain? This is, let us mark it A, let us mark it B. So how much it is a certain? 0.8, 0.7, 0.5. This is given in the question. Now we are going to find out certain equivalent cash flows. Certain cash flows, or we can say adjusted cash flows also we can say, or certain cash flows. So which is A into B. So that is C we are computing. So 1,80,000 into 80% is coming out to be 1,44,000. 2 lakh into 70% is 1,40,000, and 2 lakh into 50% is 1 lakh. Now this is certain cash flows. Now certain cash flows, either you can continue this chart from here, or you can again rewrite this thing. That is certain cash flows, you can rewrite here, or you can continue the same chart if you have the place to write. So 1,44,000, 1,40,000 and 1 lakh. Now I want to check whether these future cash flows, if I discount at the rate of 10%, then what should be the investment that we should do? So we are going to discount at the rate of 10%. So PVF at the rate of 10% for 1 year, 2 year, 3 year is given in the question, which is 0.9091, 0.8264 and 0.7513. So if I multiply, we get the discounted cash flows, that is discounted or present value of cash inflows, certain in cash inflows. So 1,44,000 into 0.9091 is coming out to be 1,30,910. This is coming out to be 1,15,696, and this is coming out to be 75,130. So if we add this present value of cash inflow, obviously certain cash inflows. So how much investment you should do if you want to earn 10%, this return if you want to earn at the rate of 10%, how much should be the investment as on today? So this 3,21,736 should be your investment, but you are being asked to do the investment in this project, how much? 3,40,000. So your NPV is coming out to be negative, that is 18,264. Negative NPV is coming. So you should not invest in this project X, because it is not even giving you the certain cash return of 10%. Okay. Now let us check for the same for the proposal project Y. Yes. Now for proposal Y, again we are going to prepare the same statement. Yes. Statement showing NPV at the rate of 10% for proposal Y. Now again, years we have to write year 1, 2, 3, and what is the cash inflows given? Uncertain cash inflows, UCF, is given to us 1,80,000, and it is given in the question, you can check, 1,80,000 and 2 lakh. Then certainty equivalent factor, this is A, let's mark it B. Certainty equivalent factor given to us is 0.9, 0.8 and 0.7. So if you want to find out the certain cash flows, then you have to multiply A with B. So it is 1,80,000, 90% is certain. So 1,62,000 multiply karne, after multiplying 1,80,000 into 0.8 is coming out to be how much? 1,44,000. Then 2 lakh into 0.7 it is coming 1,40,000. This is certain cash inflows. Now you can continue in the same page. You can continue in the same page by multiplying with present value factor at the rate of 10%, 0.9091, 0.8264, and then 0.7513. So you will be getting the present value of certain cash flows, right? So 1,62,000 multiplied with, I am continuing the same table. Here I have discontinued the table and continued in the second half in the second later page. So I'm doing the same calculation on the same page. So I'm finding out the present value of these certain cash flows. So 1,62,000 discounted at the rate of 10%. How much is the present value? So it is 1,47,274, 1,92,000. Simple calculations. 1,40,000 multiplied with 0.7513 is coming out to be 1,05,182. So present value of cash inflow, certain cash inflows, is coming out to be 3,71,458. What does this mean? This implies that if you want the certain cash flows from this project with certainty, if you want this much at the rate of 10%, this much should be your investment in the project. Because if you want 1,62,000, 1,44,000, 1,40,000 after 1 year, second year, third year at the rate of 10%, then this should be your investment as on today. So 3,71,458 should be your investment. Are we supposed to make 3,71,458 investment? Answer is no. What is the present value of your cash outflow? Only 3,30,000. So your NPV is coming out positive at the rate of 10%. How much? 41,458. You are getting more than 10% return with certainty, which is a very good thing. You are getting with certainty more than 10% return. Hence, answer is very clear, decision is very clear. Project X NPV was negative, project Y NPV is positive, so project Y is to be accepted. Decision we are going to write, since the NPV of project Y is positive, the project Y should be accepted. Now, in the same question, there is one more thing regarding project X. We should write, and project X should be rejected since NPV is negative. Now, this is very clear. We have understood certainty equivalent factor. Now, in the B part of the question, they have asked us something different. In the B part of the question, they have asked if risk adjusted discount rate method is used. Now, this is my second part of my lecture. So, I cannot explain it now, but a little bit I want you to explain which project. Forget about the risk adjusted discount rate method. Just answer this portion. Which project should be analyzed with a higher rate? Now, what does this implies? Let's have a discussion. Now, we have understood that if we want just the certain cash inflows, then we should be investing in project Y because we are getting more than 10% certain return. Okay. Now, this is something new that we have learned, that we are evaluating certain cash flows. But the project is not going to give you 1,62,000, 1,44,000, 1,40,000. This is the certainty you are going to get. But we are expecting a cash inflow of 1,80,000, 1,80,000, 2,00,000. These are not certain cash flows, uncertain. But we are expecting these cash inflows. Now, if you want to evaluate these cash inflows, you should not use 10% rate of return because this is risk free. And these cash inflows include risk. So, definitely these cash inflows should be evaluated with higher discounting rate. Okay. Because what is discounting rate? What is discounting rate? Discounting rate is nothing. Discounting rate is basically time value of money. And time value of money, the rate at which the money is increasing. Now, this is this includes three parts: inflation rate, real rate of return, and risk premium, right? Now these two parts is represented by RF, that is nominal rate of return. Now if you are just talking about nominal rate of return, if you are just talking about the certain cash inflows, the project should be evaluated at the rate of 10%. But if you are including the uncertain portion also, then you should get extra return. And if more risk is involved in the project, more return we should expect, right? So if we add this portion of return in this 10% plus this, whatever the return, let's say 6%, 7%, 8%, whatever the return is we want, keeping in mind the risk involved, this becomes RADR. RADR is what? Risk adjusted discounted rate. Now your discounted rate is, if suppose I consider 6%, then it becomes 16%. Now this 16% is after including the risk portion, then it becomes risk adjusted discount rate. Now what is this 6%? This is the return I should get because I'm investing in a risky proposal. So while evaluating the uncertain cash inflows, we should not take only 10% discounting rate, we should increase this discounted rate with the third portion, that is a risk premium. Now more risk premium should be more discounting rate, higher discounting rate if more risk, higher RADR if more risk involved, and lower discount RADR if less risk involved, right? So now let us see in which project more risk is involved and less risk is involved. Let us see. Now here if you evaluate, 90%, 80%, 70% returns are certain. But in the project X, 80%, 70% and 50% returns are only certain. Certainty equivalent factor percentages are less here. Here you are less certain how much will come. So uncertainty proportion is more in project X. Certainty proportion is less and uncertainty proportion is more. So this project is more riskier. If you want to invest in this project, you should get more return. Otherwise, why would I invest in a risky proposal? So my answer to the B part, complete answer will be, complete answer in the B part would be since certainty equivalent CE coefficients, that is the percentages of project X is lower, certain cash inflows percentages are lower, coefficients you can say. We are talking about this, my dear students, please observe. We are talking about these percentages, these certainty equivalent coefficients you can say, or factors you can say. These are less, lower side, they are at the lower side in project X as compared to project Y. In project Y they are higher, you are more certain how much you will get. So more risk is involved in project X. This can come in your objective question also, that if certainty equivalent factor of any project is low, that means more risk is involved, okay, is lower than project Y. The project X is riskier than project Y. Therefore, if risk adjusted discount rate method is used, then project X would be analyzed with higher rate. Why higher rate? Obviously, project X involves more risk, and if any project is having more risk, we would be like to have more return. So the discounting rate will increase in that case. Okay, so please write down the answer now. This is the final answer. Only one question is there in your CMA module. Only 14 questions total are there. 9 to 10 concepts are there. So almost 1 or 2 questions are there of each concept. Okay, please write down the answer. This is the first page. I hope you have written the answer of question number 8 of concept also. I'm putting up each page. Please pause the screen and write it down. This is the question number 8. The conceptual question. Okay. So pause the screen and write it down. Pause the screen and write it down. I'm changing the sheet. I'm changing the sheet. Pause the screen and write it down. Pause the screen and write it down. I'm changing the sheet. I'm changing the sheet. Pause the screen and write it down. Now this I was explaining you about the RADR since we have not studied as yet. This is a very small concept. We have just started also now. And this was your second part answer. Okay. Pause the screen and write it down. Now please observe another question. Now this question is in your CMA module as question number 1. And again a very simple concept of certainty equivalent approach concept. So let us read this question. A financial manager is looking at a project proposal whose cost of capital is 10%. So 10% will be our discounting rate. Now the project requires an initial investment of 15 crore and provides cash inflow of 20 crore and 25 crores at the end of first and second year. So there are 2 years cash inflows. Initial investment is given to us 15 crore. Each year cash inflows will be 20 and 25 crore. Then the life of the project is only 2 years and its salvage value is nil. That means in the last year, terminal year, there will be no further inflows except this inflow. Second year, this is going to be the inflow. First year, this is going to be the inflow. In the last year, second year, there will be no other inflow from the project. Okay. Going further, the management feels that certainty equivalent coefficients are 0.85 and 0.75 for year 1 and 2. So they are telling you that 85% of cash inflows are certain of first year, and for second year certain cash flows are 75%. Then it says the risk-free rate of discount according to the analyst is 8%. So if you are analyzing your certain cash flows, then certain cash flows should yield 8% return. Why? Because risk-free rate of return is 8%. So we should get 8% return if we are analyzing certain cash flows. Compute certainty equivalent cash flows. So certain equivalent cash flows will compute and advise on the project. So they want your advice on the basis of certain cash flows, not uncertain cash flows. We have to check whether certain cash inflows, outflows are giving us 8% risk-free rate of return or not. So very simple. Let us put the figures in the question. Now in our question, see, this is your particulars. 2 years project it is. So it is a very simple question. Only 2 years figures are there. This is your year, and this is going to be your cash inflows, right? So cash inflows, let me write for the first year and second year, correct? Now the cash inflows for first year are 20 crores. So figures are already in crores, 20 crores and 25 crores, right? Now, first of all, let us find out certain cash flows. So let us multiply it with certainty equivalent factor. Now, what is your certainty equivalent factor? For the first year, 85%, second year, 75%. So let us multiply with 0.85 and 0.75, right? Let us multiply. So we are going to get 20 into 0.85. So we are getting 17. These are what? These are certain cash inflow, right? Clear? Then for the second year, let us compute 25 into 0.75 equal to 18.75. 18.75. Now our question will start that whether these cash inflows are after doing initial investment of how much? Initial investment was, after doing an initial investment of, let us see how much was initial investment, 15 crore. So after doing initial investment of 15 crore, are we getting an 8% required rate of return? Required rate of return is how much? On risk-free returns, if we talk about, is 8%. So are we getting 8% return or not? So let us discount these cash inflows at the rate of 8%. So discounting factor will be 8%. So let us find out PVIF, because each inflows will be discounted. So present value factor at the rate of 8%. How do we compute 8%? We have to divide 1 upon 1 plus discounting rate. So 1 upon 1 plus 0.08. So it is basically 1 upon 1.08. So let us compute on the calculator. Yes. Let us compute. Now 1 divided by 1.08 equal to, so it is 0.926. You can round it off, 9.259, so 9.26, and again I am pressing, let me write here first, 0.926, and for second year you just have to press equal to, so you will get 0.573, 0.573. Now you have to multiply the cash inflows with the present value factor. You will get this is your future value. You are multiplying with present value factor. So you will get what? Present value of cash inflows. Let me write here. Present value of cash inflows. Right? So let's multiply 17 with 0.926. So you are getting 15.742. 15.742, correct? Then 18.75 into 0.857. So we are getting 16.06875. So we can write it like this, 16.069. Up to 3 decimals we are taking figure, 16.069. Now total present value of cash inflows are how much? Let us add this figure, these two figures, plus 15.742. So we are getting 31.811. 31.811. This is the present value of cash inflows. Now let us subtract what this figure implies in general sense. Obviously, we have to advise on the project, so we are finding out NPV. So basically, this implies that if you want, return of 20%, so if you want after 1 year 20 crores, after second year 25 crores at the rate of 8%, then you should invest 31.811. This should be the investment. If you invest this much, this money will grow at the rate of 8%, 20 crores and 25 crores. Now we are being asked to invest how much? What is the total present value of cash outflow? How much are we supposed to invest in this project? Only how much? Let us see. Initial investment is how much? Initial investment is 15 crore, right? So let us subtract 15 crore here. And then let us find out, yes, what is your, this is going to be, NPV is coming out to be 31.811 minus 15. So we are getting 16.811. So your NPV is coming positive. This means what? That you are being asked to invest less and still you are going to get 20 crores and 25 crores after 1 year and second year. That means your rate of return is more than 8%. So hence you should accept this project. So this was a very simple and basic question given in your module. Please observe, as per the basic NPV criteria, the project is acceptable as NPV is positive. Okay. So this is your solution. Please write it down. Such a simple basic question. You just have to understand that cost of capital given was 10%, but we are not going to use this information. Why? Because we have been told certainty equivalent factor, coefficient. You can see here. So they are trying to tell you to focus on certain cash inflows instead of focusing on certain uncertain cash flows. These are uncertain cash flows, but when we multiply with coefficient factors, we are getting certain cash flows. We are certain after 1 year we are going to get 17 lakh and 18.75 lakh. Now we are checking that after doing so much of investment, whether our inflows are increasing at the rate of 8% or not. Okay, so please write it down. Very simple question. Such small questions can be asked in the exam. Please write it down. Pause the screen and write it down. I'm scrolling the page. Pause the screen and write it down. I hope you have understood the certainty equivalent factor. Very easy concept, can be asked in the exam, practical portion also, and objective. Objective question, what they can ask you is that if certainty equivalent coefficients, that is the percentages, are higher, that means good, suppose if I say 0.90, that means what? The 90% is certain that you will get. So the risk is less. But if CEF is low, then that means that there is more risk in the project. Okay. Now, thank you for this session and let's meet up in the second session. Thank you.